Hello, and welcome to this presentation entitled Choosing the Best SAP High Availability Configuration to Meet Your Needs. My name is Harry Aujla, and I'm the EMEA Pre-Sales Director at SIOS Technology. For those of you who are not familiar with SIOS, we specialize in delivering high availability and disaster recovery solutions to ensure uptime for key mission-critical applications and databases such as SAP and SQL Server. Our wide range of solutions allow us to help companies with their availability SLAs, regardless of platform, operating system, application, or database. Part 1 of our presentation aims to explore how key pieces of an SAP environment can be protected to maximize uptime for the SAP application itself and for any related databases, particularly in terms of helping companies meet their availability SLAs. We'll discuss some of the challenges companies face today in how they need to achieve their availability SLAs across their IT infrastructure, and we'll also talk through how a typical SAP architecture is presented and highlight some of the areas within this architecture which possibly require additional protection from an availability perspective. The core part of the presentation will outline some of the common architectures that customers use to ensure operational smoothness and high availability for SAP, whether this is being deployed on-premise, on physical servers or virtualized servers, or if running SAP on a cloud platform. The aim here is to emphasize key considerations that need to be taken into account, depending on how you might have SAP deployed today or how you might be planning for a deployment in the future. Part 2 of the presentation continues the discussion around achieving SAP SLAs and introduces SIOS technology and our capabilities for protecting SAP. We'll emphasize the importance of SAP uptime and discuss how we measure availability to help us define those critical SLAs for SAP. We'll then introduce some of the technologies SIOS deliver through our portfolio of high availability clustering solutions and provide some examples of how some of our customers are leveraging and benefiting from our solutions today. To start the discussion, let's take a high-level view of how IT infrastructures are being managed today. Over the last decade, the emergence of virtualized computing and now cloud computing has offered key benefits for reducing cost and improving IT agility and flexibility. Companies have moved away from traditional data centers made up of physical servers to what we refer to as the new data center. Now, the new data center could be made up of a mix of platforms where some applications may be suited for physical servers, others may be better suited for virtual servers, whilst further applications may be suited for cloud platforms. Whatever the case, we're seeing an increasing number of companies who are leveraging all of these platforms at the same time. So what the new data center gives IT is the flexibility to deploy and configure their applications in a way that best meets their business needs. This flexibility allows them to change and adapt much faster to new business requirements. However, despite these benefits, these IT modernization initiatives can create new challenges, particularly when it comes to maintaining established application service level agreements. This is emphasized further when dealing with core mission-critical applications like SAP. SAP is the heartbeat for many organizations in terms of their day-to-day operations, and thus it's critical that SAP is architected, deployed, and maintained in a way that maximizes uptime on the core SAP components. The importance of SAP uptime can be emphasized further by reviewing what a typical SAP architecture might look like. Although SAP includes some inbuilt intelligence to protect itself from potential downtime, this is by no means bulletproof. This architecture outlines the various layers that one would find in a typical SAP environment, starting with the web layer at the top, down through to the presentation layer, the application layer, and finally the data or database layer. We've also represented some of the typical components outlined within each of these layers. When thinking about high availability for mission-critical SAP landscapes, one of the common misconceptions is that availability is delivered within the SAP technology stack itself. Although this can be true to an extent about some of the key functions within the landscape, there are several other functions which, from an availability perspective, can present a single point of failure. As we all know, a single point of failure is defined as part of a system or architecture that, if it fails, stops the entire architecture from working. One of the key objectives when building a highly available architecture is that we must eliminate any single points of failure. This means that when building high availability for SAP, this needs to be approached and architected very carefully in order to maximize uptime. These unprotected functions include core SAP pieces such as the central services, the on-queue service, the file system, and any databases, which are all critical for the smooth running of SAP. If any of these functions were to become unavailable through either an application, a server or instance, or infrastructure outage, this can warrant the whole SAP system to become unavailable and cause disruption to business operations. To counter some of these potential issues, SAP deployments can be architected in many different ways, depending on the needs of the customer and their business. However, this can present further challenges in that thinking about resiliency and efficiency across these architectures can also vary, with some key pros and cons across these architectures that are worth exploring further. The following slides will detail some of these architectures further and measure and discuss their advantages and disadvantages. There are several architectures one can consider to eliminate those single points of failure we highlighted in the previous slide. Let's briefly introduce what these architectures are, and we can then explore these further over the subsequent slides. Firstly, we have a configuration referred to as an all-in-one. This is usually a cluster configuration built up of two nodes in an active-passive formation, where the active node is the node that is running all of our SAP functions. We'll then look at a configuration based around protecting the database and the SAP tiers and integrating our network file system or NFS. Again, this is a two-node configuration. However, both nodes are active here, with the database and NFS running on one node and the application on the other node. We'll then take a closer look at a similar configuration where again we're looking at protecting the database and SAP tiers, but this time with NFS separated. This now turns into a three-node configuration where NFS is on one node, data on another, and application yet on another node. We'll compare this with a configuration which is not running either NFS or our on-queue replication service. This is a variation of the other configurations where some companies opt not to run these particular services. And then lastly, we'll look at an SAP multi-node HANA configuration. And this is a configuration involving multiple nodes which are laid out in a symmetric distribution fashion. As we compare these architectures, we also want to measure them by a number of key metrics that can all have an impact on defining the SLA of your SAP architecture. So firstly, we'll look at a metric around ease of management. How easy is it to install components and how well can they be managed? We'll look at reliability, and this points towards the time between a system failing and then working again as expected. This is very tightly related to availability, which talks towards the probability that a system is operational at any given time. Serviceability. How easy is it to service or maintain the system? Cost or total cost of ownership. We'll look at the cost of not just procuring your configuration, but also look at some of the ongoing management costs. Performance. How easy is it to optimize various components or functions for performance? And lastly, we'll look at scalability. How easy is it to grow the system as and when the business grows to account for aspects such as an increased number of users or applications, for example. As we talk through these configurations in more detail, let's keep these metrics in mind and discuss their strengths and weaknesses. Firstly, we have an all-in-one configuration, which is built up of two nodes. The first node is actively running all of our SAP functions, which are highlighted in green. Node 2 is fully redundant, except for running the on-queue replication service as a background process. Given this, this is still referred to as an active-passive setup, where Node 2 is redundant and will only come into service if Node 1 becomes unavailable. Comparing this against our key metrics, this configuration is favorable for being easy to manage, as we only have two nodes to consider. There is a limited level of availability here should Node 1 fail, but the configuration is also cost effective, as again we're only considering two nodes in total. This is a good place to start any basic SAP availability setup. However, there are other configurations that can be considered. The next configuration talks about running our data and SAP tiers whilst integrating our network file system, or NFS. What we have here is an active-active setup where some functions are running from Node 1, in this case NFS and our database, and others from Node 2, our application and on-queue replication service. Each node is a backup for the other in the case of a node failure, so there is some accommodation for availability here. However, there is no backup function for NFS on Node 2, so if Node 1 were to fail, we would lose NFS in this configuration. This would be deemed as a single point of failure and could warrant the whole architecture as being down. Our costs are still very similar to the all-in-one architecture, as again we are only working with two nodes, and because we're now utilizing both nodes for active functions, we can potentially optimize each node based on the functions they are running. In scenario 3, we have another data and SAP tier configuration. However, on this occasion, we have now separated out NFS to a separate node. This three-node configuration, ignoring the presentation node for the time being, allows us to provide some additional resiliency and scalability for NFS. NFS is actively running on Node 3 and is using Node 1 as a backup. We're still performance optimized here, as we can fine-tune each node towards the functions they are running, and we've also added some scope for serviceability, allowing for each node to be serviced individually without having to bring the entire architecture out of service. What you'll notice is that this configuration begins ticking more of our key metrics boxes. There are some companies who, for various reasons, choose not to deploy the ERS and NFS functions. This might be suitable for less critical SAP environments, because it's easier to manage with only two nodes in total, and it also provides some level of availability. It's also somewhat performance optimized as well, allowing us to run specific functions on specific nodes. However, this is not an overly common configuration, but it's worth bringing into this discussion purely for comparison. Lastly, we have a scenario involving HANA databases. HANA can be scaled out across multiple nodes to deliver further resiliency. The illustration here depicts a three-node HANA setup with a separate node for our application. The notion here is that Node 1 is using HANA System Replication, or HSR, to replicate data to Node 2. At the same time, Node 1 is also replicating to Node 3. Some companies might look at deploying Nodes 1 and 2 as a local high availability setup using synchronous replication. Node 3 could be at a DR location, relying on an asynchronous replication model. If in the scenario Node 1 goes down, Node 2 can take over. If Nodes 1 and 2 were to go down, Node 3 can take over. This configuration meets many of our key metrics. Given the multiple nodes and how they're deployed, we can deliver a high level of reliability, availability, serviceability, performance, and scalability. On balance, however, again, given the number of nodes and their configuration, one would also have to accept that the costs for running such a solution could be considerably higher than some of the previous configurations we've looked at. In summary, we've been looking at some of those common configurations companies consider to meet their SLAs for SAP. There is neither a correct or incorrect approach, as each company is unique and thus has different requirements for what they need from their SAP landscape. This means that they will measure their SAP requirements in different ways. However, if you are thinking about deploying a new SAP landscape or re-architecting your current SAP infrastructure, there are some useful pointers to take away. Think about ease of deployment, and this doesn't just mean deploying and installing your solution, but also taking into account procurement costs and ongoing management or support costs. Availability of the architecture is also key. How many different points of failure can you endure? What duration of downtime will be unacceptable for the business? In terms of serviceability, how easy is it to carry out maintenance, patching, backups, and any other changes with minimal impact to uptime? Think about SAP application performance. How predictable is the application's performance? How easy is it to optimize and fine-tune? Does the application in this configuration perform as expected by the business? And lastly, think about efficiency. How well are the resources being utilized? Is there over or underutilization occurring on nodes or functions, which thus could be impacting our operational costs? I hope this session has been insightful and has developed some further thinking points with regards to SAP and some of the challenges companies face when addressing SLAs for SAP. Part 2 of the presentation continues the discussion around achieving SLAs for mission-critical applications and introduces SIOS technology and our capabilities for protecting SAP. We'll emphasize the importance of SAP uptime and discuss how we measure availability to help us define those critical availability SLAs. We'll then introduce some of the technologies SIOS deliver through our portfolio of high availability clustering solutions and provide some examples of how some of our customers are leveraging and benefiting from our solutions today.